Section 6-4, multiple representations, fractions and decimals. And actually our essential question for this whole chapter is, how can we represent numbers in different ways? For instance, 1/2 is the same as 5/10, is the same as 50 hundredths, is the same as 50%, and of course we could go on forever with different representations. Before I carry on though, go ahead and pause, take a look at your answers, whatever the assignment number is. This is for page 155, 157. Pause, come back when you're ready for the next page. And onward to page 159. Pause, come on back when you're ready. All right, so again, our goal for today, convert fractions to decimals, and yes, decimals to fractions. Now, we've already kind of changed fractions to different representations, changed mixed numbers to improper, changed improper to mixed. Now we're going to change from one decimal format, from one format to another. Decimals to fractions, fractions to decimals. And of course, this is going to be needed because sooner or later, you're going to come across problems and or equations with multiple formats. Well, change them all to fractions and mixed numbers, or change them all to decimals, and they will be more easy to solve those problems. All right, whatever the date, whatever the assignment number, go ahead and pause, write the page and the numbers down, come on back when you're ready. Now, in this case, to turn decimals to fractions, I use the 3R acronym, even though I'm going to kind of smile when I say that because it's not truly 3 R's. We're going to use the idea that we're going to read the fraction correctly. We're going to write the fraction as we just read it. And of course, we will always check to reduce. Now, using our place values, let's take a look at example 1. If I see just the 1, it would be 1/10, but in this case, it goes to the hundredths place. So I'm going to read this as 15 hundredths. I'm not going to allow any of my students to say 0.15. Tell me what that means. So we read it as 15 hundredths. We write it as 15 hundredths, 15 over 100. And now we reduce. The greatest common factor of both is 5 for a final answer of 3/20. Taking a look at the next example, reading it appropriately would be 0 and 8/10. So I'm going to go ahead and write 8/10, 8 over 10. I read it, I wrote it, and now I'm going to reduce it 4/5. Last one is tougher, perhaps tougher. This says 125,000. So I'm going to go ahead and read 125 thousandths. I'm going to write 125 thousandths. And now I'm going to reduce. Now, by the way, yes, you could reduce by 5 repeatedly. So if I reduce by 5, that would be 25 over 200. If I reduced by 5 again, it would be 5 over 40. If I reduce by 5 again, it would be 1 over 8. But a heads up that you could have saved yourself time if you had noticed that the greatest common factor of both of those is 125. Maybe you wouldn't notice that right off the bat, so don't worry about it. One way or the other, you should get to simplest form of 1/8. So read it, write it, and reduce it. I'm going to ask you to pause, put time in for yourself. Come on back when you're ready. First one you can write originally as 75 hundredths, reduced will go down to 3/4. 6/10 will reduce to 3/5. 201 thousandth, folks, does not reduce. If you are struggling with reducing, especially big numbers, my strong recommendation is to write the first several prime factors and just go in order. Does 2 go into both? Well, 2 goes into 1,000, but not into 201. So cross off the 2. Does 3 go into both? Don't forget that 3 divisibility rule. 2 plus 0 is 2, plus 1 is 3. So 3 does go into 201, but 1 plus 0 plus 0 plus 0 is 1. Okay, 3 does not go into that. So 3 does not go into it. 5 goes into 1,000, but not 201. 7, I don't believe goes into 0, and guess what? That is in fact simplest form. So if you do struggle with reducing, I would suggest for the next couple days, even the next week, write those numbers once a day over and over and over again, and then you can just go in order, and that should help you with simplest form. All right, let's carry on now with the other direction. Now there are 2 methods for rewriting fractions as decimals. And just to remind you, These are going to be the same quantities, just written in different ways. Method number one, ask yourself, I don't know if this disappearing ink is going to work. Nope, didn't work. How about this one? Always check, can the denominator be changed into a power of 10? In other words, can it change into 10? Can it change into 100? Can it change into 1,000? Anything like that. If it can, your life just got easier. For instance, as an example, 3/5 can be changed into 6/10. And of course, if you now know that 6/10, you can rewrite it as 0 wholes and 6/10. Another example, 25 can be turned into hundreds. If you multiply both numerator and denominator by 4, you now create an equivalent equation, 1 and 16 hundredths, equivalent mixed number, excuse me. And then we can rewrite it with 1 whole and 16 hundredths. Now that's all fine and dandy when the denominators can be converted, but what about things like 3/11ths? 11ths cannot be turned into tenths, it can't be turned into hundredths, it can't be turned into thousands. What do we do then? Well, method number one is great when it works, but method number two always works, and that is simply understanding that we are dividing. A fraction, what does a fraction mean? Well, it literally means you're splitting a whole into parts, right? Please make sure you're dividing numerator by denominator. So this is 3 divided by 4, and this will be 3 divided by 8. Even if you messed up, folks, you can catch yourself. Let me just mess up. Let me act like it's 4 divided by 3. If I were to do this, 4 divided by 3 one time, 1 3 is 3 with 1 left over. Bring the 0 down, and I'm going to stop right there because I'm going to ask myself, how the heck do I have 1 whole? There's no holes in front of this. So even if you accidentally mess up, you should be able to catch yourself with your number sense. I can't have 1 whole when there's no holes. And if you divide it backwards, then you can go back, you can catch yourself, you can fix it. Now, I chose to do this problem because, to be frank, most of you have this one memorized anyways. But notice we are dividing 3 by 4. And don't freak out that there is 0 holes. Good, there should be no holes. In fact, every time you finish up, check that your holes match up and check that your parts are reasonable. 3/4 is more than a half, 75 hundredths is more than a half. Let's go ahead and do 3/8 together. Again, make sure it's 3 divided by 8. Now you may add as many zeros as you want, but don't turn that into 3,000. We still need that decimal point to show that it's 3 divided by 8. Also, don't stress if there's a 0, because after all, there are no holes in front of the 3/8. Some of you bring the 0 down, others you don't, that's okay. Now 30 does divide into 8 2 times, just kidding, 3 times, with 24 and 6 left over. Now don't forget, always check that your remainder is smaller than the divisor. If this had been a 9, we would have had to cross off the 3, go back, and start again. You can't just keep on moving with the extra parts. So always check your remainder. All right, because we could not pull any more 8s out of 6, let's bring a 0 down. 60 pennies divided among 8 students. Well, each of those would get 7 pennies. And just when you're getting frustrated, Mr. Cowan, this one keeps going on. And actually, in this case, it does in fact reach its conclusion right here. So 3/8 could be rewritten as 0 and 375 thousandths. Same amount of pizza, same amount of money, just a different way to write it. Don't forget, check that your holes match up. Check that your parts make sense. 3/8 is a little less than a half. 37 pennies is a little less than a half a dollar. I'd like to tell you that all decimals are that easy, but some are not. And again, let's go ahead and do these together. If you want, you can go ahead. No, actually, let's do these together, and then I'll have you pause for some extra practice after that. 2/5, the first question we ask, can the denominator be changed into a power of 10? And in this case, it can. 2/5 can be changed into tenths, times 2, and times 2. And now that we have it as a power of 10, we make sure the 4 goes in the tenths place. Ask yourself the same question here, but we've already talked about this. Can 11 be turned into tenths or a hundredths or a thousandth? The answer is no. So we're going to come off to the side. We're going to divide 4 into 11 parts. And yes, it makes sense that it's got 0 holes because there were no holes in front. Decimal, put as many zeros as you want, but make sure you have the decimal in the proper place. 40 divided by 11 is 3. Excuse me, Mr. Callan, that was a 9. That was a 9/11, apologies. All right, 90 divided by 11 is 8, with 2 left over. 20 divided by 11 is 1, with 9 left over. And of course, every time I'm always checking, is my remainder less than the divisor? Now at this point, some of you are saying, wait a second, something's funny about this, because we get another 8, and then we get another 1. And it's just going to keep on going, isn't it? Now, I'm going to be honest. At this point, I'm going to say you can write this answer. Please don't write 0.8181 repeated, because I'm going to ask, why are you doing? No, the video's not skipping. You're just being redundant. You don't need those extra digits. You do need the repeat bar over both the 8 and the 1. But I would argue you learned that last year. So how do we crank this up a notch? Homework in our textbook is trying to challenge you today, because it's going to say if it does not divide evenly, it's going to say go to the thousandths place, write your remainder as a fraction, and of course the denominator is still going to be 11 because the whole thing was cut into 11ths. So we can write 9/11ths as 0.81, and both of those are repeating, or you can write it as 818,000th and then another 2/11ths of a thousandth. Now this is what I'm really going to push you on. So let me do another example. For 4 1/3, you got 2 options. Option number 1 is to change it to an improper fraction first, which I gotta admit, I kind of like. And I kind of like it because at this point, I can write, well, oh, of course it's 4 holes because originally it said there were 4 holes there. And of course there's one left over because originally it said there was 1 piece left over. So that's one reason I kind of like this method. The other method, though, is to pretend that the 4 is not even there. You can simply divide 1 by 3, and then later on at the end of the problem, go back and put your 4 in. Now, either way is fine by me. I'm going to go ahead with the first one. So I'm going to bring a 0 down. 10 divided by 3 is 3, with 1 left over. 10 divided by 3 is 3, with 1 left over. And of course, 10 divided by 3 is 3, with 1 left over. And there comes the remainder. So I'm going to write that remainder as 1 over 3. Again, it's not wrong to write 4.3 repeated. In fact, students with strong skills will be able to do so. But I would also argue that students with the strongest skills can write it in multiple ways. Those all represent the same amount of pizza, the same amount of money, the same quantity. They're just represented differently. One is a mixed number, the other is a repeating decimal. The other has a decimal with a fractional remainder at the end. P.S. Don't forget, when you are checking those remainders, check to see if they can be reduced, because sometimes they can. All right, here's the point where I'll remind you, terminating decimals, terminate, stop. Think about the root word of that. Terminate means end, stop. Repeating decimals, all you have to do is repeat the digit that repeats. If it's 1, if it's 2, make sure it's both. But as I just showed you, I'm going to ask that you're able to write it like that as well. That's going to be part of the challenge. All right, here's where I want you to stop. Pause your video, complete these problems, come back when you're ready. All right, so 4/9 will actually be 0.4 repeating, and if you're trying for the challenge, which I would encourage you to do so, I believe the remainder, was it 4? I think so. I think that works. Is it? Wait, I'm gonna challenge myself here because for some reason this is seeming like I'm not knowing what I'm doing here. So let's go into it. 3, nope, just kidding, 4, 36, 4 left over. Yes, Mr. Callan, there's always going to be 4 left over. So it is 4/9 at the end. Doesn't always work out like that. Apologies. 5/8, 625 thousandths. 1/10 is, well, 1/10. 4/5 is the same as 8/10, so you can rewrite that as 8/10. 5/11 is another one of the repeaters. And 11/20 is going to be 55/100. Just to help some of you that need the challenge, let me do this one real quick. I'll do it in black so I can show you in red what that remainder is going to be. Actually, just go to the thousands place, right? So 11 doesn't divide, but this one does. 44 with 6 left over. 11 goes into 60 5 times. With 5 left over, 11 goes into 50 4 times. With 6 left over, and so I'm going to write 6/11. And that's what I was concerned of. Notice that doesn't look exactly the same. I didn't want you to think that it's always the same fraction at the end. It is not. All right, folks, that's what I got for today. If you're in class with me, I'll have you do a couple problems right away. If not, whatever the assignment is, whatever the number is, page 161, 4 to 37, 42 to 45, take care, do well. Let's grow. See you, folks.